So apparently that last video got cut off. What I was saying was that in order to have survive, you got to have water, food, and then you also have to have oxygen, which we get from our air. Remember that only a small percentage, less than 20% of the air that we breathe is oxygen, and yet it's vital to our life. And then our body takes that oxygen and it changes it metabolically to the nutrients that we need, and then our body takes it to where it needs to go. Then we have to have heat. We cannot survive without it. Not only do we need it so that we don't get frostbite on our fingers and toes, but we also need it to help control our body's metabolic processes. We need it in order to maintain our core body temperature, so that our body functions the way that it's supposed to. If we lose that core body temperature, bad things start to happen, and our body just cannot function. Our blood pressure drops. Our blood pH drops dangerously low. We cannot turn our food into the right kind of energy. It's just a lot of bad things happens if we don't have the right heat. And then there's the pressure that we were talking about. Pressure, remember, is just caused. The physics definition of pressure is the force applied to a given amount of area. And we feel pressure from all different kinds of places. We feel pressure from the air that hits us all the time, but we also feel different kinds of pressure as well. Now, atmospheric pressure, we have to have that to breathe. We can't live on Venus because pressure is way, way too much, but we have to have that pressure. And then there's something called hydrostatic pressure, and we have to have that hydrostatic pressure. I'm learning to be able to keep our blood flowing. If we didn't have that hydrostatic pressure, our blood would not be able to flow. And this is one of the reasons that if you ever go scuba diving, you have to have the proper scuba gear. You have to have scuba gear to keep the pressure regulated, not just for breathing, but so that your blood pressure will stay regulated to a good flowing pressure. Otherwise, your blood vessels would rupture, and well, that would just be ugly. It wouldn't be good at all. Okay? So let's look at the next thing. Then there's something called homeostasis. Our bodies are phenomenal, y'all. They are just phenomenal. God designed us beautifully. Because we have so many fail-safes, all these things about maintaining this stability in our bodies and how important it is to maintain all this pressure. Our diaphragms, if you push really hard on your diaphragm, if you've ever gotten kicked really hard and got the wind knocked out of you, if you play football or if you play basketball or baseball, or even if you've just got a mean older brother like I had. One time I didn't move quickly enough when he was quote-unquote boxing, and he hit me and knocked the wind out of me. That's exactly what we're talking about. You have to have that proper maintenance of pressure, and if we don't have it, then our diaphragm cannot act properly. So we have so many homeostatic or homeostasis controls that allow us to have a stable internal environment for our bodies. These control mechanisms to make sure they're fail-safes, to make sure everything's working just so in our bodies. It's awesome what happens inside there. These little homeostasis monitors, they control things in there to make sure it's all good, and that if there's something wrong, it corrects it. So there are three parts. There's a receptor that says, hey, let's see what's going on, and let's see how everything's working. I'm going close to this hot stove. Oh, I feel that it's hot. I better back away. And I mean, that's a very overly simplistic example, but that's how it works. And then there's this control center. A lot of times it's your brain. A lot of times for more complex systems of your body, it's a lot more complex than that. That's called the control center or the set point. And then there's the effector. And these are the places that elicit some sort of response. if it's like touching that hot stove, it's just simple enough to say, oh, let me back away, or oh, let me let go of that hot object. On a lot of other times, if it's something that's more serious in our body, whether it's blood pressure or whether it's something going wrong with our digestive system or bloods, if we're white blood counts or whatever it is, then that effector is going to say, let's see what we need to do to fix this. So that's exactly how it happens. The receptor recognizes that there's some sort of change in our environment, internal environment, and it sees that, and it sends it to the control center and says, oh, let's see, how does this compare to what it's supposed to do? And then the effector says, oh, what muscle or gland do I need to say, my arm is connected. It says, let me back off. Let me, endocrine glands or pituitaries, whatever it is that says, do I need to run? What do I need to do to fix this until it's fixed right again? And here's this is in your book. Let me see if I can find the page. There's a really good picture in your book. It's on page 7 of your book that kind of shows that this is how it would happen if your body core temperature got maybe too hot. And it shows it exactly that your brain kind of sees that, and so it says what all happens, okay, that regulates our own body temperature. So this is in there, and I could draw all over this screen for you and kind of show you, but I think that your book does a really great job of showing that. So you look on page 7 and kind of study that and see what happens, and see how that how it's showing you how your skin, your blood vessels get smaller, and your sweat glands start to activate to kind of cool your body when it's getting too hot. And so that's exactly why we sweat and how it works and exactly what happens. And it's totally cool how it works. All right? And then there's 2 different kinds of systems. There's negative feedback systems, and then there's positive feedback systems. Remember what these are called: homeostatic control mechanisms. They are our body's regulators to make sure that they maintain a nice, even environment for our body to function at its best. Okay? Notice what negative feedback. Negative feedback to me means that's bad. But for this system to work, negative feedback is good. It notices something negative happen, like we're too hot. So this negative feedback summary kicks in, and we say, oh, we need to sweat to cool down. So that's actually not a bad thing at all. So it prevents these sudden severe changes in our body. It corrects our set point, which is our body's like control center that says what is the best temperature for our body to be, what is the best optimum body, everything for our body to run at. Blood pressure, heart rate, temperature, everything for our body to function at its best. That's the set point, okay? And it causes the opposite bodily disruption to occur. So that's why it's called negative. So if our body gets too hot, it says, oh, I need to make the negative happen, so I'm going to cool it off. If our body gets too cold, oh, I need the opposite to happen, the negative of that to happen. So that's why it's called negative feedback, okay? And it's called a feedback loop, which again is on page 7 of your book. And there's the most common types right there: body temperature, glucose regulation. So these are people with that have diabetes. This loop, this negative feedback system, doesn't work right. It's got a problem with it. All right. And then we're not going to do these animations, guys. So then the last little thing here, I know I'm going over my time a little bit, but these things, I want you to know these cavities. And cavities, oops, I didn't mean to go to the next screen. I want you to know these, oh my goodness, go back. These cavities, I want you to know them, okay? These cavities mean, I want you to know what, it's entering drawing mode so I can draw on it here. This is the cranial cavity. And cranial is brain. So that's the cavity. Cavity is just what it says. It's a hole. So a cranial cavity, it makes sense. That's where our brain goes. The vertebral cavity, guess what that is? That's where our vertebra, that's the cavity or the hole where our, okay, the thoracic cavity, that's our chest cavity. the diaphragm. That's where our diaphragm goes. The abdominal cavity, that's everything related to the stomach. Pelvic cavity, okay? Thoracic cavity, here's a front, this is a side view, and then on the right is your frontal view, okay? I'm going to expect you to know all of those as well. I want you to be able to label diagrams. Miss Hawkins is going to have diagrams for you to label if she hasn't already given you those. I'm going to expect you to know those pretty clearly. All right? We're good there? It's asking me, do I want to save the changes? Yes, I do. All right. And then I'm also going to want you to know all these words, and they're big words, and I know I've run over my time, but I want you to know these words. These are just two of the cavities and the membranes. This says thoracic and abdominal. Thoracic and abdominal membranes. This visceral, that says visceral layer. The visceral layer is the layer that actually covers the organ. So you have a visceral layer, or a layer that covers your heart, and then you have a parietal layer. That word is parietal. Parietal layer, that's the one that lines the inside of the cavity. So it doesn't cover the organ itself. It lines, it's like a lining around the cavity. So your thoracic cavity then has this lining around it. Our stomach cavity, it has a lining around it, and that lining, I didn't mean to turn the slide. That's called the parietal. So we have a thoracic membrane, and those thoracic membranes have a visceral, remember, that actually covers the organ, and then it has a parietal that lines the cavity, and that next word is pleuria. Visceral pleuria and parietal pleuria. Visceral pericardium, you know what that means? That's heart. Visceral pericardium and parietal pericardium. So that's lining the heart and the heart cavity, the chest cavity there. And then you have the abdominopelvic membranes. Okay, they told me how to say this last week, and I had it in my head, and then you have the parietal one and the visceral. Remember what visceral does? That actually covers the organ. Parietal lines the actual hole that it sits in. It actually covers the membrane. Okay? Make sure you get those distinct, because I'm going to ask you. So you see this picture right here. You can see the actual pericardium here. Let me get back to it so I can go back into drawing mode here. You can actually see this lining right here. That little lining right there, and this again is in your textbook, and I'm going to expect you to know this. These are really good drawings, and they're on page 10 of your textbook. Okay? On page 10 of your textbook, it shows you. And you need to be very familiar with them. These are on page 10 and 11 of your book. And it actually shows you really good pictures of the membranes, okay? And it also shows you the pericardium. It shows you the visceral pericardium. It shows you everything that there, and you can see it all. The pleural cavity, the parietal pleuria, it shows you everything. So you're going to have to, there's so much that you're going to have to learn in this, okay? And you need to know the difference between them. Okay, you're going to have to learn all those. Look at all that. You're going to have to learn what a vertebra is, where it's at. You see the spinal cord in that picture. You see the aorta. You know what the aorta is. That's your big artery going from your heart. Inferior, there's all that. You're going to have to learn all that. All right? Oh, I keep forgetting I have to get out of drawing mode. All right. All right, and then the last thing that we're going to talk about on this slide, show right here, is that I want you to know that the main body systems, the main organ systems, and I never really thought about skin as being an organ, but it is. And this one here, let me get back to this. I really went long with this video. I was going to really try to stick to half this time. I really was going to stick to half this time. This right here, integumentary system. Learned a new word. That's our skin. That's our skin. Okay, that's an organ. Okay, then our skeletal system, and then our muscular system. We're going to learn all of those. Okay, all of those this year. All right. And then the other systems that we're going to talk about are the nervous system, and then the endocrine system, and that has to do with our, including our reproductive and all different kinds of glands, our thyroid glands, our all pituitary glands, all those kind of things, all the glands in us. Okay. Then we have our cardiovascular. That's heart, pulmonary, anything to do with pumping of any bloods or anything. Then our lymph nodes. I did not know we had so many lymph nodes until I saw this picture. Look at all of those lymph nodes. We have them everywhere, everywhere, everywhere. Okay. And then we have our digestive system, our respiratory system, our urinary system. That includes our kidneys and our bladder. And then we have our reproductive systems for both male and female. Okay, those are all the different systems that you're going to have to know. All right, and then that's all I'm going to do for tonight, because we will talk about all the others, but that's all for tonight. I'm done for tonight. I've way longer than I intended, but you have a great week. Be looking for quizzes. I'm going to be putting quizzes that's going to span this whole chapter. We only have 2 more sections from this chapter. Then we're going to have a test over chapter 1. There's 18, I think, chapters in this text, and we're about to finish chapter 1. I am working on, there are 20 chapters in this text, and we're about to finish chapter 1. So we're going to go fairly quickly, but there is a lot of material. Study hard.